class.
Good morning, madam.
I'll be your physics teacher. Welcome to this new academic year. I'm Miss Noeme. I'll be taking you for physics for the whole entire year unless and until something comes up or whatever. Welcome to our first physics class. Today will be just a basic touch on the introduction of what you need to know about physics. What is physics? For you, physics may be a new term, but for some of you, you must have come across it. That's why you're choosing this subject, physics. And I just want to let you know that physics is not really that tough subject. Everyone, first of all, I have to thank you for taking up this challenge of taking physics. It's not that hard, like everyone usually says, but I know you can handle it. You've chosen this subject, so I hope this year will be a good ride for both you and me. So let's get straight into the subject. We will not wait for another day. We'll be wasting another day. We'll get straight into the subject. So first up, we have music roulette. Music roulette is sort of a motivational activity that will get you hyped up for us to start off with today's lesson. So music roulette, this is how it goes. I tell you the 6 basic units. I give you the quantity name. You give me a song that's related to that quantity name. So the 6 basic SI units, those are just the 6 main units that you need to know by heart, because this will take you everywhere. Anything you do with physics, this thing is in it. So let's start with quantity. When I point at you, you sing a song. So quantity number 1, mess. Yes, Tumuna.
Everything's been messed up lately.
That's one. That's mess. Mess. Everything's been messed up lately. Every time you come, quantity in physics. Quantity, mess. Everything's been messed up lately. Oh, that's one quantity, mess. What comes under mess? Kilogram, kg. That's all you gotta remember. Every time you hear that song, everything's been messed up lately, you remember that quantity of mess. Remember that quantity of mess. Number 2 is length. Length. Anyone? Length.
Me, please.
Okay, go. Shoot.
And he's bigger than me, taller than me, and he's stronger than me.
Shorter than me. He's not a little bit longer than me. Everyone knows that song. JV, that one. Yes, that's according to length. So every time you hear that song by Justin Bieber and that dude, you remember that. Length. Quantity, length. He's older than me, taller than me, and stronger than me. That's length. It comes on the length. Okay, we'll go. Last one. Another one. Time.
Don't miss my time.
Good.
Time.
That song. Please don't waste my time. So you know, these are just the 3 main ones. Since now you know, I want you to know this by heart. Your 6 basic SI units. These 6 basic SI units is the, let's see, it's going to open more doors. These units will help you derive new formulas. These small 1 by 1 units, they make new formulas in future. You need to know this by heart, because this is very important in physics, because with this 6 you'll make the other formulas come in. So thank you for participating. We'll start off the class with what is physics. What is physics? What is physics? There could be other places you get physics from, maybe from the book, like encyclopedia, from the Google. You can get it from everywhere. Physics is everything that's around us. That's what some people say. But then we'll just stick to what we know and what is being written in the textbook. Okay, so moving on. What is physics? What is physics? Physics, according to the textbook, is physics simply involves measurements. So a standard system of units is used to measure physical quantities. So it's the standard units. In physics, you'll come out the jargons of quantities, measurements, how big, how small things are. So all this involves is basically what physics is involved in. It's just basically describing the standard of quantity. That's what you're gonna learn today. The standard of quantity. So basically, physics is like trying to find out the quantity of something. Quantity of something, and it's so finding its standard. Quantity of something, the quantity of something, looking its value of that missing thing. That's what basically what physics is. So physical quantities, it says physical quantities are quantities that have physical properties of objects and units of measurements. For example, 2 kilogram, 1 meter, 10 feet, 1 kilometer. Those are physical quantities. You are 5'6" centimeter, your height. How heavy are you? 60, 70, 80, 100 kg. Those are physical quantities. Kg, the unit symbols, the kg, meters, centimeters, those are physical quantities. So that's just basic introduction of what physics is. Physics, simply the standard system of units. That comes to what we learned today. The main topic of the day is International
System of Units.
Say it with me.
International System of Units.
International System of Units, or what we know in physics, what every physics person knows as the SI units. The SI units. The SI units, International System of Units, are the basic units. The 6 main basic units that will open the doors to other formulas, other physical quantities, other unit symbols, other unit names, other quantities. Okay? So this International System of Unit, or the SI unit, was established by the internal agreement. This gang is like an association or something, not important. And it consists of mass in kilograms, length in meter, time in seconds, temperature in Kelvin, luminous intensity in candela, and substance in mole. Mass in kilogram, length in meter, time in seconds, temperature in Kelvin. What does it mean by this? Whenever you weigh something, when you weigh something, for example, if you want to weigh a potato. So when you weigh it, you don't say, this potato weighs 2 meters. No, because it's from beginning, mass is measured in
Kilogram.
Mass is measured in kilogram. So whenever it comes to mass, something heavy, something that has weight, it will be measured in kilogram. That's good. So when it's mass in kilogram, length, how long something is. How far did I travel today? I have walked how many meters? I've walked 10 meters, 10 centimeters. So length in meter. Kilogram, these are the parts of kilogram. Kg, in weight. Weight, you have kg, milligram, and etc. But according to the SI units in physics, every time you see a mass, make sure its standard unit name is in kilograms. Unit symbol kg. Every time you see something in, what if it weighs, a potato weighs 10 milligrams. When it says milligrams, what do? Always you have to convert to kilograms, because the SI unit, it says it has to be in kilograms. The same goes with length. Length in meter. In meter, sometimes you have, so that's distance. Distance, we have meter, kilometer, meter, centimeter. But according to physics, SI units, whenever you measure something, the distance of something, its length, how long, how short something is, it should be measured in meters. Always in meters. Anytime you need to convert something, convert it back to meters. If it's in kg, change it to meters. If it's in centimeters, you need to change it to meters. Always back to meters. Same goes. Time in seconds. In time, what do you comes under time? You have hours, minutes, and seconds. But then the SI units tell you that whenever there's something involved in time, you measure it in, what's the word? Seconds. Always measure time in seconds. Whenever you're solving a problem in physics, when it's related to time, measure it in seconds. Temperature in Kelvin, in luminous intensity in candela, and substance in mole. That's what you're going to learn today. So what I'm basically going to want you to do, you guys going to have to try and remember this by heart. You need to know the difference between the quantity, its unit name, and its unit symbol. These three are very important in physics. If you do not write one of these, if you get this wrong, you lose a mark, 1 mark. If you get this right, the mass right, unit name wrong, you get a half mark deducted. Half mark, kilogram. If you write, for example, you said, I weigh the potatoes, how many kg, like you've solved the problem, yeah? For example, area. Area is equals to length times width. These are both measured in meters, so length in meters times meter, it will give you meter squared. You don't write this meter squared, like for example, length is given as 2 and width is given as 4. So 4 meters, 2 meters times 4 meters, 4 twos are
12.
4 twos are
12.
4 twos are 8. 4 twos are 8. 4 twos are 8 meters squared. So you get this 8 right, you get your calculation part right, but then you forget to write this, the unit symbol. You get this wrong, you could lose half mark or even a mark. You don't write a formula, you'll get your formula wrong. That's losing 1 mark. So always remember, the little things count when you're doing physics. The little things count. So mass, now let's store this in our hearts now. So let's go. Quantity. What's the quantity of quantity? The quantity name is mass. Quantity name is mass. Unit name is
Kilogram.
Say it loudly. Mass.
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 Kilogram.
Unit symbol.
Kg.
Kg.
Unit symbol.
Kg.
Unit symbol. Kg. So I'm gonna hide it. Mass. Unit
Mass.
name.
Kilogram.
Yes. Mass. Unit name, kilogram. Unit symbol, kg. You have to differentiate these two. Unit name, the whole meaning of this small k and g. So length, the quantity is length. What's its unit name?
Meter.
Meter. Unit name,
Meter.
unit name,
Meter.
Meter.
unit symbol,
Meter.
small m.
Small m. Small m.
Say it.
Small
Small
m.
Length in meters, small
Small
m.
m.
Unit symbol,
Small
M.
not capital, small m. Time in
Second.
Seconds.
Small
Small
s.
s.
Small s. Mind you, some unit symbols they have capital letters. Some unit symbols they have small letters, small alphabetical letters. So it's like this, but these basic SI units they have small capital letters, small letters, small letters. So time in
Seconds. Small s.
time in seconds, small s. Temperature measured in Kelvin,
Kelvin.
measured in
Kelvin.
capital K.
Capital
You
K.
see the difference? This one is capital K because it's temperature. Temperature, Kelvin, capital K. See? Luminous intensity, candela, small c, small d. Substance in mole, MOL. Mole. You'll be measuring stuff using this. This is the unit symbol. Very important. Okay? Don't forget this. Anytime you see mass, you measure them in.
Kilogram.
Anytime you see mass, you measure in.
Kilogram.
Length
Small m.
in meters. Length in meters. Mass in kg. Time in seconds. Okay? Remember that. Keep that in mind. So, moving on. I want to test you on this. Mass. Quantity is mass. You measure mass in.
Kilogram.
Good. You measure time in.
Seconds.
And you measure length in. Length.
Length.
I'm walking somewhere. You measure it in.
Meter.
Good boy. You measure it in meter. So we can move on now. You know it by heart. Keep that in your heart. Continue today. I know it's our first day. You'll get there. Moving on. So now that we know our SI units, we will be deriving the formulas. We will derive the formulas. Derived units are formulas that are made up from these SI units. You see, derived units. What are derived units according to the textbook? Derived units are products or ratio of fundamental units. SI units are also known as fundamental units. Fundamental units. Fundamental meaning the basic units. Anytime you come this word, fundamental, basic, or SI, those all mean the same thing. Those are your basic 6 SI units. So, what are derived units? They are products or ratios. They are a combination of the SI units. That's what it means. Combination of SI units. That's what it means by derived units. For example, it says velocity. Velocity is denoted by the letter V, capital V, denoted by the capital V. So it says, for example, velocity. Velocity is the change in length. V is equals to length. Length is denoted by L per unit time. Per unit time. Length per means divide Per means
Divide.
Per means
Divide.
per means divide. So velocity is equals to length
Length.
per unit
Per.
time. So per, you put a small dash at the bottom and you put divided by time. D is equals to length divided by time. So what do you want to do? Length divided by time. When you measure length, you measure it in
Meter.
good boy. Measure length in meters and time in
Seconds.
seconds. You see? It says, for example, similar the unit of speed is similar to the ratio of unit of length divided by time. So from these are two different basic units. When you put them together, they give you velocity. Velocity is the same thing as speed. And then when you do that, you differentiate them, like you put it in word form. Length per time, you put length on the top because it comes first in the word. Length per unit time. So length divided by time. Length divided by time is that's what you do. Length divided by time is equal to, then you try and find you're trying to find their unit symbol. And the unit symbol is, length is measured in meters
Meters.
and time is measured in
Seconds.
seconds. So that's what you call derived units. See, from these 6 basic SI units, you were able to make a new formula. You found out how to calculate speed. Speed and velocity are the same thing. Speed is equals to distance divided by time. Speed is equals to distance divided by time. The same thing as length divided by time, which is measured in meters per second. Speed is measured in
Meters per
What's
second.
another name for speed? Velocity.
Velocity.
Velocity is another name for speed. You'll be coming across now in the physics, it will be mostly they'll be using velocity. So same thing, velocity is the same thing as speed. Velocity is the same thing as speed. So since we've done that, for example, velocity, there's another example that's given here. For example, area. What is area? You'll be coming across these words: area, velocity, volume, excuse me. Those are new physics jargons. You'll be seeing this every now and again. It's like kind of gonna be a cup of tea now, so know them by heart. So what is area? Area is the amount of space taken up by a body and is measured in square meters. Square meters. Area is the product of length and width. Why did they say square meters? So square meters, your formula for area, example 1, area. It says area is equal to length times width. And it said also that it will be measured in meters squared. Why do you think it's measured in meters squared? Length, what is the unit symbol for length? Meters. Small m. And the measurement for width, when you measure something, how wide something is, you measure also in meters. So if the base are the same, m times m will give you m squared. M times m will give you m squared. Same base will give you the same base, and you add the indices. M times m, same base, you put the base at the bottom. 1 plus 1 will give you 2. Same base at the indices. This is math sali, max talingo. Same base at the indices. So m divided by m times m will give you same thing as m squared. That's simply what it's trying to give here. What derived units means, it's gonna make you, from the 6 basic units, it's gonna give you that. Another one, the other example given is volume. Volume is like something that you're trying to measure inside, you know, the container or something. Volume is equal to length times width times height. So L is measured in m, width is measured in
Height. Wait.
width is measured in m, meters is also measured in meters. M go, that means meters. M times m, and height is also measured in
Meters.
m. Height is also measured in meters. So m times m times m, same base, will remain as the base. Then there is a 1, 1, 1. M, 1 plus 1 plus 1. 1 plus 1
2.
plus 1.
3.
3. M cubic meters. So area is measured in meters squared,
Meters squared.
and volume is measured in
Meters.
cubic meters. Say it.
Cubic meters.
That is read as cubic meters. That's what it means. Okay? Cubic meters. That's how you read it. Cubic meters. M to the power of 3 is same thing as cubic meters. Say it.
Cubic meters. Cubic meters.
M to the power 2 is the same thing as meter squared. Meter squared, remember that. To the power of 2 squared. To the power 3 cubic. Set?
Right.
Okay, so we'll move on to our class activities. Our class activity, I've been giving you your class activity. Turn to page 48 of the textbook. You have your class activities with you.
Yes, madam.
Okay.
Start.
Okay. So I'll do number 1. We'll all do number 1 together. So number 1, it says class activity. Okay. Class activity. Number 1. Don't have to worry about the formulas. You'll get to know about the formulas by heart. It says, given D is equals to M over V. You must be wondering, what is D? D is also known as, when it's denoted by capital D, that means it's density. M is always mass, and V is the volume. So D is equals to M over V, that means density is equals to mass over volume. So that means it says, given D is equals to M over V, find D. You need to look for D. We need to look for D. Always write your data in doing physics. Find D when M is equals to 2.5 and V is equals to 50 cubic meters. So now that you have written your data, you know that we need to look for D. So the formula is already given. So you know the formula. D is equals to M over V. All you got to do is to insert the values. So we're looking for D. So just bring M, kota sumumay 2.5. Then since it says divide, put your division sign. Divide by 50. 50. Make sure you write your unit symbols. So 2.5 kg and 50 cubic meters. So 2.5 divided by 50 that will give us 0.05. Mass is measured in kg, and volume is measured in meter cubic. So your answer is 0.05 kg meter cubic. Cubic meters, sorry. 0.05 kg cubic meters. So 0.05 cubic meters. If you don't write your unit symbols, it's like you say 0.05 monkeys. Remember, your unit symbols are very important because this will distinguish what is what. Okay, if you're looking for area, then remember it's square meters. Meters squared, cubic meters, volume, cubic meters, speed, meters per second. Okay, always know that. So now I've given you your class activities. I want you to do it now. Stop. Anyone need any help? You done with your... Okay.
I'm done.
Ready to explain?
Yes, madam. Ready.
Okay. What's your question?
Newton per meter squared.
Okay, I'll read out the question to you too. P is equals to F divided by A, so it's 6,300 newtons divided by 30 meters squared. 30 meters squared. So what do you think would be the answer? According to your calculation, what was your answer? What was your answer, Tikini?
Newton per meter squared.
What's the answer? 3,600 divided by 30 will give you 210
Newton per meter squared.
Newton per meter
Squared.
Newton per meter squared. Don't forget to do your calculation before you write your unit symbols, okay?
Alright.
And Setfano, your question was, where's my other pen? Your question was, if volume is equals to V is equals to L times width times height, so your values are 3 times 1.5 times 1. What is your answer?
4.5
4.5 cubic meters. 4.5 cubic meters. 4.5 cubic meters. So, I hope you've learned something today, since you guys have done with your exercises, exercise 1, exercise 2. I hope you've learned something today. I want, for today's homework, I just want you to recap on the 6 main international units of system. Try to express yourself, try to memorize whatever way, whether it be a music roulette or maybe rapping of something, in order to grasp the formulas by heart and for you to know the things by heart. This is very important in physics, and I hope you've learned something today. So I want to test whether you've learned something today or otherwise. So in mass, how do you measure mass?
Kilogram.
Good. Time
Seconds.
and temperature.
Meters.
Temperature
Oh.
is the only one with the denotation of capital K. So, and it's the name of a person.
Kelvin.
Good boy. See? Maybe we can say temperature. That boy's name. What's his name? Kelvin. So there. See? So you've learned something today. So I hope this will be not our last class. I'll be seeing you again at 2 for our first lab class. So I'll be seeing you around. Thank you so much for listening. Thank you for paying attention in my class. I hope you learned something today, and I'll be seeing you in the next physics class. Hope there'll be, if there's anything, any questions, any queries, come to me. Do not be scared. If you think something I said was wrong, if you know there was something that was missing somewhere, we are both here to learn, you and I. So I am willing to accept whatever you have in mind. Thank you for listening, and I'll see you in the next class. You have a good day, and pay attention to also your other subjects. Don't just concentrate on this subject, please. Okay, you take care and stay safe.
Thank you,
Thank
madam.
you.
Bye.
Because they can sit properly. I'm not gonna see you in the second semester, Lisa.
Why?
Because you need to hire someone. You never give me money. Because when